Hey guys, long time no see. Welcome back to another episode of the Real Hacker Hours podcast. This is basically where I just do my normal set project work. I just hit the record button before I do it. Today I'm going to be picking up where I left off with my Requiem tool, which is effectively just a static bug finder. You give it code and it'll find bugs. I just grabbed a random FTP server off of GitHub and I'm just going to try running against and see it. What happens, I ran against it already, and this is the summary of what it found. It found rules with fgets variable rate, fgets desk static, and sprintfs. I want to see if I can actually use any of these for a security bug, and if so, what fun things I can do with that. So, we see here is the listing of all of the instances of sprintf with the %s found. Let's start looking through some of these. Let's try no. Let's try source path.c. Well, first off, were we able to compile it? Yeah, we were able to compile it and run it. Okay, cool. Let's check out path.c. According to this, line 18 has the first one. I'm gonna bring this over here for convenience. Gen real path. Okay. Not sure where this is called from. Looks okay, so this function, soctor name, we see that it's passed in a path variable which gets written to a char sterling. Okay, cool. So the destination buffer in here is the result of a string that's allocated via malloc. Size of malloc is size of char times length of the dir named passed in, which is the first string, plus the length of the path plus 5. So on paper, I don't see, due to the fact that it's writing in the data to a buffer that's allocated directly based upon the length of the string that's going to be written. I don't see an overflow happening there. However, let's continue looking. Number 26, what's, wait, path. Next one is 63 and 65. Let's take a look. 63, temp path. Okay, so this one looks a bit more interesting. You see here's there's a sprintf here, a sprintf here. Looking through them, trying to see what the difference is. Looks like the only difference is just with the format string. This one has a forward slash in it. This one doesn't. Both are writing to temp path. Both have 2% s's. First argument is soctor name. Second is cut path with that. So one thing that's looking a bit interesting is looking at how this buffer, it's allocated via malloc, which here we're seeing that this size is a size of path plus a constant size 1024. However, the value of rating is path and dir name. So if we have full arbitrary control of both of these arguments, we should have an overflow. We might not. It could be caused by there's a size check somewhere else that would lead to this not being a bug. But okay. Cool. So if we have both arbitrary control over both of these, we don't have a bug, but I'm sorry, if we have full arbitrary control over both of these strings, we do have a heap overflow here, but I'm not sure if we do. Let's continue looking to see if there's just a blatantly easier one we can exploit. Let's check data.c. Go to line 26, entering passive mode. Okay, cool. So we're seeing here the format string. So this is the response to a passive command, which what a passive command does in FTP is, if I recall correctly, passive entering passive mode. It has this serve yeah, whoever the recipient is, it will have them list the information so you can connect to it. The first four octets are the IP address, and the last two are the port. We're seeing here for each of the port octets, it's doing a %s, where the arguments are the various strings of IPS, which we're seeing comes from the split IP. I don't think we're going to have too much control over that, so I'm going to continue looking. This is data.c. Anything else in data.c? Nope. Okay, cool. Let's take a look at directory.c. Okay, so we're seeing another sprint of current directory, length dir name, string length. Okay, another instance where it's copying into a heap buffer that right before it is allocated that it is going to be that size via stir length. So, okay, I don't think that's a heap buff we have. Only one directory.c. Okay, cool. Let's take a look at login.c. 61 message buff some. Okay, same thing. It's a buffer that is allocated via malloc, so no dice there, where the argument is the stir length of buff sysname, which is the same data that's being written. Okay. Next one is down up list 78. Command equals malloc size of char. Response. Gig. It looks like, okay, so command is set to a static size of 128. However, the thing that's being written, I'm not seeing a size check, although granted general path. What this is looking like is the command that's being written, which is that's output buffer ben ls tackle %s. It's looking like that's probably like a get current listing. Or actually, I was initially thinking that just because I'm a little bit tired, it could be like a command line option. But what it could be is this could be how it. One of the FTP functionalities is it will list all of the files and directories in a directory. Ben ls tackle. This could be how it's doing it, and if it is, this resb might be the directory name. And if we control that in this context, due to the fact that this is a statically allocated buffer, if we control RSB subset 1, we have a heap overflow. For that, okay, let's just make a note of that. Interesting things. What file is this again? Down up list. Down up list.c. 78. Okay, cool. And let's try reply code 67. Let's see what's here. Okay, we're seeing here it's another instance where this string is being copied to a buffer with %s. However, that buffer is being allocated to basically that size. Okay, cool. Looks like the only interesting thing from here is this down up list.c on line 78. Also, the reason why I'm doing this, going through and trying to like find bugs with this tool, is hopefully by using this tool more and more and hopefully using it successfully, I can effectively see what this tool lacks in and hopefully make it better. And also see if this tool is actually like good at its job of finding low-hanging bugs. Okay, cool. So this is just one thing, sprintfs. We evaluated all of the rules for here. Other ones we see, f gets desc static. I want to take a look at those next. So let's take a look at server.c. Okay. Line 22. Okay, cool. Yeah, we can see it's writing into buff, which is a stack pointer. Not a stack buff pointer, a stack buffer. However, it's only writing in effectively the size of it -1, so I don't think that's going to be something we need to concern ourselves with. 83. F gets size of buff. Okay, same thing. It's writing to a stack buffer, yes, but the size of actually one thing that's a bit interesting. We're seeing here that it's doing size of buff, whereas beforehand size of buff -1. I'm going to pause the stream real quick. Okay, what it's looking for is I remember that f gets it will terminate the string with a null byte. Looking at this right here, it will read in at most one less than size and then append the null byte to the end. I forgot if it was like it would append the null byte after it wrote size amount of bytes, size being the second argument. But no, it will write at most this size parameter -1 and then append the null byte after that. Cool. So we looked at those. Let's try f gets variable right. Okay, same thing. Okay, I might need to, well, yeah, I might want to edit the rules because this is a constant. However, it's not detecting that. Reason for that being is how it detects if this is a new, it checks if there's a number in it, and if so, it flags it as a constant, whereas this is a string, so it's not doing that right. Might need to fix that. Cool. Okay, so we basically looked at all of them. Only one we really found was this one right here, so let's take another look, see if we can actually get something interesting from this. Okay, cool. What I'm going to try to do now is here. I'm going to try and throw this up in a debugger and see if I can't actually hit the code path for that. So hang on a second, it's that attack planet. Just I need to list looking at here, I need to list the port and the directory path name. Let's do sudo gdb server run 111 and let's do this as the path. FTP server. That's interesting. It's claiming that Oh, let's try this. Run port 1111 and run with the temp directory. Change directory. I wonder if the arguments are flipped based on what the docs say. We'll just try running this as a normal user. Okay, this isn't working. I'm gonna move on. So yeah, it appears that for some reason this isn't working as expected. So I'm gonna go ahead and leave off the video here. We used Requiem, found some potentially vulnerable code, and like looked at all of the pieces that could potentially give us RCE. Didn't find other than this, although having a bit of hard time running it dynamically, and I don't feel like spending the time to figure out why that is. So yeah, didn't find too much interesting stuff, but first time making a video back for a while, so oh well. Thanks for watching. See you guys later.